Recording. Okay, so we are now recording, and I'm going to share the screen. Okay, so we are now sharing the screen. We are recording, and let's just go over to the course website. Oops. All right, machine learning foundations. So here, we are currently, today is February 2nd, and I've updated the calendar up until this. So this is the video from last week, the performance metric. We went over the machine learning pipeline code and accuracy, so I went over that. And then if you remember last week on the 24th, we did KNN. So what I want to do now, usually I spend a little bit more time at the beginning because we're bringing everything together. Okay, we're putting everything together. So in this example today, I'm literally just going to merge this with this. All right, so that you guys, so you have all the pieces, and I just do this once. So as you can see, it's called linking performance metrics with KNN. So hopefully here, now we're gonna have a complete pipeline, and that will be like the first chapter, if you will, of the course. All right, so today I conclude like this whole idea of doing a machine learning algorithm from scratch, doing everything from scratch. So if you've looked at, we looked at Numpy to play with the data, we've looked at KNN, how the algorithm works, and we looked at how to evaluate and measure performance. So now we are just bringing everything together. So today we'll work on the Jupyter Notebook, and then hopefully we'll finish this up today so that next week, we can start the sequence of singular value decomposition, which is a topic in of itself. So it's its own topic, but it goes well with after KNN, right? And then just keep in mind, as a reminder, the exam will be on February 14th. That's exam 1. So it'll be your first exam. Remember, it's a closed notes exam. So it's a closed notes exam, but you're allowed one cheat sheet, 8.5 by 11. So once we finish singular value decomposition, we'll get into the probabilistic methods. So things that have to do with probabilities. And so we'll talk about Bayes' theorem, and we'll talk about the Gaussian function. So that should be a lot of fun. And we'll see, the algorithms that are related, that are most probabilistic, which is a very, very, fascinating area. All right, so before I get started, I guess I should ask, are there any questions? No questions? You guys can hear me well?
Yeah, loud and clear.
All right, great. All right, excellent. So yeah, all right, so audio's on, video's on, recording is on. Excellent. All right, so let's start then. So what I need to do is I need to open up the Jupyter Notebook. So we're going to do that. And like I said, today we just have to, and this might be very easy for you, or or very obvious, or not at all, right? So either way, my point is you really need to understand everything that we're going to do today extremely well, all right? And after that, everything that we do is just variations of that. So it won't be KNN anymore, it'll be other algorithms. But this is the complete thing that should take data. Your homework assignment for this one will be to either load IRIS or MNIST or both. I'll think about it by the end of class. But using this code, you should do the analysis pretty much like what you did with WECA, right? So you did WECA last week, it's due tonight. So I'll be grading that. I'll be grading something this week. And now you're just gonna repeat the same assignment of Weka, but obviously this time you only have one algorithm, KNN, because we're building the algorithms. As this is a machine learning foundations course, we're looking at the code from scratch. All right, so let's go ahead and start the Jupyter notebook. Okay. Okay, so my Jupyter should start. Or not. All right, let me try it again. I don't know. Oh, there it is. Oh, there it is. Okay. Okay, so you should be seeing the Jupyter notebooks here. And I want to start with the code that I worked on Monday. So if you remember, I set this on Monday that we were going to take that code and just work with it today, right? So it should be this one, performance metrics. So I'm going to click on that. Remember, I introduced the sklearn library. So we're also using that one. And so we can see here, we already got a lot of this to work. We had data sets, we had train, test, split, we had the metrics. So I've gone over this. And if you don't remember, just go back to the video. Now here, usually what you do with this is that you make all of these, every single algorithm like a class, right? So you're gonna make it like a class and then bring it in so that you can use it. For now, I'm just gonna keep it a little bit simpler. Just keep the code in here, but just keep in mind you can make it object-oriented if you want as well. All right, so the part that's missing is this. We know we have our data here, iris, we do the train, test, split. So that's done. And then here, as you remember, I left this kind of blank from last week, but we have to now integrate it. We have our own accuracy function, and then I just created some fake data to test the accuracy score and the performance metrics that we were able to print out here. So now what we're gonna do is we're gonna merge it with the KNN algorithm. Okay. So we're gonna do that. Let me just pull up my notes here. Okay, so we did. So we're gonna bring in the KNN. Now, usually when we do something like an algorithm, we're gonna have two functions. We're gonna have train and test, but this time around, KNN, if you remember, it's a lazy algorithm, and as such, it does not need training, right? Because everything is kind of just done when you're testing. So for now, we're not going to need training, but we will need training, in other functions. Okay, so let's go ahead and open up the. Let me just grab the code. I don't want to type it up again, so I'm just going to grab it from the GitHub. You should be seeing the GitHub. And then if you go to here, right, we have the code in both these. So I'm just going to do KNN NumPy, yeah, just click on that. And then, we can look at some of the things that we need. So we need a couple of libraries. Actually, k = 5. I'm going to do copy. This over. I already had NumPy, so I don't need NumPy. Then we're going to do a Euclidean distance function that we had defined, right? So if you remember, just switch to this. So if you remember, this is the Euclidean distance function that we created. So actually, I'm going to copy You know what? I'm just going to copy that and then delete it over there. All right. So yeah. So I'm going to copy this. All right. So now I'm going to go to the Jupyter notebook. So let's go. To the let's just like here, I guess. Let's add a new line. And there we go. So we've got now all of our code in here, so that we can kind of integrate all of it. So we've got our libraries. So usually you're going to organize this a little bit better now because you have more things going on here. So I like to do these line breaks here. So I'll do like, that's the libraries. So that's the libraries. Then we have some parameters over here, right? And then over here, we've got like the KNN function definition. Oops. And then, so I've got here the Euclidean distance, right? And then now usually data sets are done after the definition of the functions, and we already have it, so you can get rid of that. And then we have the predict function, right, which was for our data. We had tested this, but now we have to make sure that it'll run for any type of data, including iris, for instance. Right, then we have over here this function. This is the main loop, if you will. So we're going to move this out of here. And that's the definition of our code. Then we've got the data set, the split. And so we've got that. So we'll probably just plug that down here. Okay, so we can get rid of this line. All right, so you guys can help me out if you see anything that looks a little odd. That line, just cleaning it up. Data. Okay, so this one here we can get rid of because we already brought it in. We've got the accuracy function, but well, let's keep it, and then we can decide if we're going to use it or not. Now here, we can keep these for reference for testing and debugging, but my goal, what I think I'll do is I'm going to do this with Iris or something, and then you guys will do this with MNIST. Numpy should be able to handle MNIST because the underlying libraries of Numpy are C in the background. Weka is such a nice tool, but they really need to bring it up to the 21st century. So they need to seriously make it GPU. So I think it's a missed opportunity for them that they're not really. It might be that the functionality is there, but it's not the fault. Anyway, so this is what we have. And then we have this function, of course, which is the one that we tested on Monday. Now, to evaluate performance, obviously now performance will all be done at the end after this. So we're going to do something like this. And that's performance. Okay, and this one also, in any case, we should bring it. So that way we have a little bit more ordered structure. So let's still keep this commented out. So what I want to do now, I simply want to test Iris, right? So I want to make sure that Iris will run here. Now so this is what we're going to do now. So let's go ahead. I'm going to save here. I'm going to clear the kernel so that we don't have any output. Everything's clear now. And then we're just going to go through the execution of this to see, because we're kind of integrating two pieces of code that were meant for different things, so they may not work, you know, right out of the box. Maybe we'll get lucky, but we'll see. Any questions so far, guys? Any questions? Making sense? What we're doing? All right, good. So then, well, teaching it KNN, right? KNN, doing everything that Weka can do, including performance metrics, but all in Python. So, all right, so we've got our libraries. I know that'll work. We've got K defined as 5. That should work. We've got the Euclidean distance, which takes 2 vectors. We already talked about this. Yeah, this should work. Then we've got the predict function. So let's go over that one. We give it 1 test sample, which should be a vector. And we calculate the distances between test X and all data samples in X. Yeah. So in X train, right. So I'm gonna pass that argument, I think, directly into the function. So we're doing for X in X train, Euclidean distance test X, X. That gives us the distances. Then we sort them with NP-ARC-sort, which gives us the indices. Returns the indices to the k nearest neighbors because we do from 0, from 0 to 5. So just slice the first 5. We have these. Then we do for I and k neighbor indices. And from Y train, we extract the labels. And then we've got some labels in there. And then with a counter, we can just pick the most common 1. And that gives us most common label for that sample. So that will, for that to work with the performance metrics, we will need to accumulate this in an array and then convert it into a Numpy array, a vector. So let's see. Here we bring in iris. So iris data, our iris target. So that works. We're going to need to bring in data from a CSV. So remind me that we need to write the code for that. Okay. And then we have X train X test, do the split. We print Y test. So that vector will be ready to go. And then we have this one and that one. I assume these two work fine. So really then, the problem is here, right? So the problem is when for a test in X test. So we need to accumulate this in an array. So I'm gonna do list of pred labels and just initialize it like square brackets. Yeah, that was strange. Okay, it looks like a curly bracket, but I think it's just cleared on my screen. Yeah, okay, so in this list now, instead of a print statement, what are we going to do? We're going to collect these in a list, right? Because it's all the values in Xtest. So I'm going to say list of pred labels dot append, and we should append then the predicted value, which we need to capture here. So instead of a print statement, we're just going to do temp pred, because it'll be changing a lot. And that temp pred is going to be added into the list. You see that, guys? So once we have this list, we have all the predicted values. So now let's do the following. Let's print all the values in list of pred labels, right? And also we're going to print, let's add a line. Let's add text. I'm going to say true labels below. You guys see that? True labels below. And now here, I'm going to say print Y test, right? Y test. So these two should be similar. If the algorithm is working well, they should be similar. I'm gonna just comment out this one for now. So let's see. Got our definitions. The data is iris. We split. I think this should work. All right, let's run it then. Let's save the file. Run. Run. Split. Prints the real labels. It'll load the accuracy function. We're not using it yet. This other one, we tested this one. We're not using it yet. Now, this is the tricky part. Let's see what happens. Oh, no, it worked, right? Good. If you remember, this would give us, the top one was what? Do you guys remember? It would give us the value, and then it would give us, I think, the count of how many were that value. Do you guys remember from Monday? We did this on Monday. So now, so it's giving me tuples, right? It's giving me tuples for every answer. I only want the first value. So it should be pretty straightforward to just say, I want out of the tuple only the first one, just by indexing it, just like that. I'm only going to add the label that I want. So then let's clear the kernel again. Okay, kernel should be clear. Let's do run, 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 run. Okay. Run, run. Okay, so this is the moment. Run. Ah, it gave me that again. Why? It might be that it's a list with a tuple on it. That could be it. So let's actually, the only way to debug this is to do print. And I'm going to do temp pred. I just want to see what's in there, so I can figure out how to correctly slice it. I'm going to put an input in here. Yeah. So let me rerun this one. Oh yeah, it wants, that's the way it works. Yeah. Okay. Just do enter. Yeah. So you guys can see the problem is that it's actually a list with a tuple. Oops, what is that? It's actually a list with a tuple inside. So when I did this object 0, I just got the tuple. So I probably need to get the tuple out of the list, and then out of that tuple, I need to get the index. So let's clear this. Oh, there we go. So it should just be probably, I just need another index. So now I've got, this one gives me the tuple out of the list. Now, if I do this, it should give me just the first in the tuple. Okay, so that's what I believe will happen. So probably, I'm just going to delete these. That should work, I think. All right, so save it, run it. Nope, doesn't like it. So now it's saying that Xtest is not defined. Where? Okay. Probably because I cleared it. I see. Yeah, I have to run everything. Okay. Now, run this one. There we go. So what do you guys think? Do you think it worked? What's your assessment just by looking at this?
I'd like to say it worked.
Why?
Well, it displayed all the true labels below, and it also showed all the data and prediction values on top like we wanted it to.
And is that enough to say that it worked? What do you want the algorithm to do?
You want it to learn.
Learn what?
Learn how to project the Y value up there, the Y prediction.
So did it? So my question is, did it learn?
I can't tell if it did.
You can't tell, really? Look at this information that's presented in front.
It looks like it didn't learn. It looks the same to me.
It looks like it what? Like what? Like it did or it didn't?
Well, it looks like it's the same.
Yeah, it looks
I
like
don't think it did.
Yeah.
What is the same?
The list and the test numbers? Or the arrays?
Okay. It seems to have worked because the outputs are the same or very similar. Good answer, right? That's how you need to think. This is the predicted values. This is the true values. The way that we assess performance is by comparing the two. Do you understand, guys? Ah, yes, exactly. This is exactly the game. This is how you're going to win $1 million, right? You're going to go to a competition, and in the competition, they're going to give you this. And they're going to say, okay, build me a model that predicts that. And then you're going to go and spend a lot of time and work. And then if you get this, and this is better than everyone else's, you get $1 million. You see that? So that's competition in machine learning. All right, so that's the idea, basically. And that $1 million will be for you to work more. It'll be tied in more funding. So anyway, now that hopefully this made sense, right? So this is what I want you to see. So they're aligned, right? So the first one is a 1, the first one is a 1, then the next one is a 0, then a 0, then a 2, then a 2, 1. Okay, so they look like, yeah, they're the same. Remember, the values are aligned, right? So let's go to, yeah, so just think of it, right? So for a test, for Xtest, let's look at this example here. For Xtest, right, you have one Xtest these are the real, these are the predicted. So the real is 0, the model predicted 0 for that X test, good. For the next X test, right, which is the iris data, so, you know, the plant data, the real is 0, the model predicts 0 given that X test, good. Then you look at the next one, the real value is 1, the model predicted 0. Ooh, no, you worry because another team got that right. So there goes your $1 million. You see, so that's the whole point of this, right? You want to get as many of these to match as possible. And so that's the accuracy score. So now, if you understand this idea, you can see that we basically have a complete pipeline here, right? We have a complete pipeline in one script. Later on, what you should consider is having 2 scripts. One is just going to be your machine learning algorithms, and the other one is going to be your performance metrics, right? And so you could actually build your own sklearn. You know, just like sklearn has all these functions, you know, your goal this semester should be actually to create your own. This is my sklearn. I can bring in all my functions and, you know, obviously make it an object-oriented project. You know, if you guys are looking for projects for directed projects or what do you call it? Senior project, sorry. This would be a nice one. I'm always all about creating your own libraries that others can use, which are very good. You know. Anyway, so now we still need to print out all these metrics, right? All these metrics. Currently, if you notice, the difference between the two is that this is a native Python list. That's why you see the little commas. Whereas this one has no commas. That tells you this is a Numpy array. Is that clear, guys? Let me grab some coffee. All right, so your homework will be definitely, since I've already done Iris, will be to just do this with MNIST, the 2 CSV files. So I still need to show you how to read in data from a text file. We'll do that in a sec. I will do it with Iris, and then you guys will have to figure out, you know, have to do this analysis with MNIST. Sound good? So that'll be your homework assignment. Shouldn't be difficult because I've given you a lot of the code, but I certainly want you to do this one, okay? Does this make sense, everyone, the homework? Okay, good. So I'll add the link later in the class, but let's finish it up. And if you have any questions, yeah, so somebody's asking me if I will upload this notebook to Brightspace. I can put it on the GitHub, and I had planned to do that. Just please remind me because I may forget at the end, okay? Yeah, definitely don't let me forget about it, but yes, I had intended to post this one as it's currently not on the GitHub. All right, so yes, we'll do that. All right, so let's go ahead and complete the task. So we need to convert this one into a Numpy array. You guys already know how to do that very well because you have done the Numpy array homework. So I need to take list of pred labels, right? The list of pred labels, and I'm just going to make it into a Numpy array. So now I'm just going to say y pred. So I'm going to use, I like to use certain conventional terminology because otherwise I'm going to get confused when I'm talking to people. So that way we all know what we're talking about. We're all on the same page. So I'm going to call it Numpy array. So you should always, once you talk about y pred should not be a list, but it should be some kind of a vector, either a Numpy array or a tensor in the proper either PyTorch or TensorFlow sense. But for now, you've only learned NumPy. So that's what it should be in, okay? That's what it should be in. So let's go ahead. So now I have my ypred in there. So now let's print it again. And you will see that now they should look a little bit closer to what they were before, because they should both be NumPy arrays. So this is actually now ypred. Okay, so they should be very similar. So now I'm going to run this one. You can see that they look now pretty close, and it's easier to compare 1, 1, 0, 0, 0, 2. Are there any misclassifications actually? You guys see any? This will have almost 100% accuracy. There wasn't a single one. Yeah, but that's uncommon, right? Remember, IRIS, there's a reason why I use IRIS. IRIS has been studied for 100 years at least. And so it's perfect for this kind of machine learning. Most of your data will be very noisy. So let's go ahead now. And now we can call the function on both of these, which would be this function, right? And hopefully this will then print out our results. So now let's go over here. So we need to, obviously, I'm just going to do res and then print stats percentage train test, y test, ypred. Now I have my, and now I'm going to do print. And it's going to be res, which is the object that contains the results. So I run it. There we go. So you can see it's perfect. We've got a 100% accuracy. We've got the confusion matrix there, precision recall, F1 metric. Absolutely perfect, and it worked. And what is that none? Sure what that one is. Anyway, so that's it. So this is the script. Okay. Now another thing we might want to do, let's go to here. I have IRIScsv. Do you guys see that? Instead of loading IRIS from data sets, because the problem with loading IRIS with data sets is that, if you remember, our initial approach was just load IRIS from the data sets from sklearn. That's convenient, but you can't do that with your own data. Let's say that you're doing a project very similar. You were hired by some farmer, and the farmer wants you to build a model about his or her crops, right? And they've got crops on, I don't know, something that they're growing. And you spend the whole summer taking measurements of, I don't know, the stem, the leaves, something like that. Those are your features. And then you want to classify based on that, based on, when should he or her harvest the plants, right? So that you're going to try to predict, wait a month or do it early or do it late, something like that. So you're building that model. You collected your data. It's just an Excel spreadsheet, basically. So you have your little Excel spreadsheet going on. But now what you want to do is you want to load that Excel spreadsheet into your model, right? And that's not going to be in dataset. So we need to have some kind of a mechanism to be able to do that. So here, I'm going to go ahead and clear the kernel again. And now if you notice, all we have to do is, we've got all of our functions. They're still pretty good. We need an X and a Y. Remember the very first homework assignment, I gave you a lot of problems, and all I said is, what is X and Y? Do you guys remember that? Because that's it. That's, whatever you're doing, you collected your data, you have your CSV. Now that CSV needs to be converted in this X and Y that you see here. Once you have that X and Y, then you can just go ahead and perform everything nicely as you've learned in this exercise. Does this make sense? Is it clear enough? Okay, so now what we need to do, so now what we can do is, instead obviously of doing it like that, we're gonna read it from a CSV. Now I have a CSV in my, let me save this. I have a CSV, as you can see here, IRIScsv. If I click on that, this is my data, right? Same thing as you would get. I have, now you should always study your file, right? So this is a text file, right? It's comma separated. You've got sepal length, sepal width, petal length, petal width. Those are the 4 features, remember, that define the sample. And then you have species, right? Which is Setosa, versicolor, and virginica. Remember, these are now text. We will need to change them into numbers. And then we just need to grab these values over here, right? And load them into our memory. So we need a script for that. Okay, so we're gonna need a script for that one. Where's my, okay, so we printed here. And I have commented out, yeah. So in here now that if I go here, right, you can see that my Jupyter Notebook performance metrics, right? I'm actually gonna rename this because it's gonna be confusing. Let me rename this to performance KNN and, wait, hold on. KNN and metrics. I'm just going to say metrics. It's not too long. Okay, so I'm going to rename that. Okay, so now. Let me. Hold on. Let me close this actually. All right, so I just closed it. All right, so are you guys seeing? Yeah, so let's go back to the Jupyter Notebook here. All right, we're there. So now what I'm going to do is KNN and metrics, right? So this is the one. I'm going to click on that, and you can see that's the code, and this is where we are. So what I want to do now is I want to read in iris.csv. So I'm going to need some code for that. Now, there are a lot of ways of reading in text data into Python. But we want to use efficient ways of doing it. So let me see, let me think about one. Probably the most efficient. Probably. Okay, let me think here. So let me see if I can find. Oh yeah, so let's try one. There's several, right? But let's try the Numpy way, which is Numpy has a function called load txt. So let's try that one. So we already have Numpy, right? We have import Numpy as np. So as I said, there's many functions. I was actually looking for another one, but I found this one. So matrix. You can check my GitHub and you'll find various ways in there, I'm sure. So matrix data, I'm gonna do n. So notice I'm not calling it X and Y. I'm actually calling it matrix data because this is gonna contain everything. So we're gonna need to slice some of it out. All right, so let's do NP for NumPy. And then load txt, right? So we're gonna load txt here. So we need to specify some parameters. So I'm gonna say the file, of course. So let's call it f numpy, the file. We're gonna open, and this is located in my current working directory. So I'm just gonna say, I think it's iris.csv, okay? And then a couple of parameters you can define. You want to tell it what's the delimiter. That is to say, what is the thing that separates the data? So usually it's going to be either the tab key, tab, which is a, I'll show you in a sec. Or it's going to be a comma, right? So in our case, if you look at the file, it's a comma like that. But if it was tab, it's usually like that. That's tab. And, but in this case, it's comma. We just saw it. Okay, and so we specified the delimiter. We also want to specify, if you remember, the first row is the names of the of the features, right? So we want to tell it to skip that row. So we're going to say skip rows equal 1. Does this make sense, guys? Is this clear what I'm doing here? Oh, and by the way, I'm sorry, I did this in the wrong place. This should have been here. Let's just try this as R for now. This should have been down here. So load text is actually where we specify f numpy, comma, delimiter, comma, and then of course skip rows. Skip rows equal 1. So that's how it should be done. Any questions on what I just did here? No questions? Pretty clear? Okay, great. So now what we want to do, obviously, is we want to print this matrix just to kind of get a feel for it, you know, what we got. Now, this is why it's so great to start with IRIS, because with IRIS, we know everything about IRIS. We know that it's got 150 samples. We know that it's got 3 labels, right? We know that it's got, we know that it's got 4 features. So we know all this. So let's test it out, actually. Let's see what happens. Now, I'm concerned that the labels in IRIS are words. And I don't know how this will react to that. So let's see if it works. NP is not, yeah, I have to run everything again. So let me do that. And now I'm going to do this one. There's an error. Could not convert string to float setosa. Do you guys see that? Guys? I thought so. I thought that would be a problem. Let me try one more thing. Otherwise, we'll try another function. Yeah, so it's not liking it. All right, so this one won't work. Do you guys understand why it didn't work? It would have worked if the labels on here had been numbers. You see that? But it's kind of nice that we did it because it underscores that this is a problem. So you either have to change these numbers before in the file itself. So you could open Excel and do, okay, replace all Virginica with 2, all versicolor with 1, and all, and all setosa with 0. We could have done that, of course. But we want to try something else because this won't work. So let me see. I think pandas might do it. Let's try pandas and see. I'll leave this in there for you guys to kind of have available as another approach for loading data. But this one, unfortunately, did not. It would work if the labels were numbers. So let's do. All right, so we're going to try another one, okay? This time around, we need the library pandas. If you remember, what is pandas? So it's got a funny name, right? We import pandas and then we say as PD, which means we can give it any name. I could say import pandas as PNW. You know, it's just a shorthand way of referring to something you imported. Not sure why it's called pandas, to be honest, but it's a great library for data science. It allows you to, do things. Obviously, right now I need something like this, so we'll try it out. So let's see if I can't do. So here, usually the convention is in pandas lingo is to call things data frames. Okay, so I'm going to say df there. I'm going to call pandas pd dot read underscore CSV, okay? And so now I would specify the location. So in this case, again, iris.csv. And also, in this case, the header will be none. So it's a little bit different in the notation. It's not skip rows equal 1, is header no, okay? So that's the idea. Let's try it because I'm not entirely sure if it'll work. Okay, let's do this one. All right, so no errors, right? So if there's no error so far, so it seems that this time around it had no problem reading in the data. Now, this is actually quite handy because you can also, you don't just have to put in like a file path in the operating system. It can also be, it can also be a URL. So, okay. What does delimiter do? So delimiter here in this one, we had to specify it explicitly. It basically means that in IRIScsv, everything is separated by commas. Do you see that? So when you do the split, the Numpy load txt will do it on comma. Do you understand? Because you could have also separated with tabs. Got it? Yeah. So in pandas, it's not necessary, as you probably wonder why they're inconsistent. They're, each thing is developed by a different group of people, right? So usually, this is one of my favorite, for startups, for instance, this is one of my favorite things in machine learning. You develop a library, let's say you develop a library for cybersecurity, or you develop a library for like, to transactions, banking transactions that might be fraudulent, something like that. And then you just build a library, and then you give support to that library to people, right? So that's kind of nice. So my point is, all of these things like pandas, Numpy, sklearn, they have been developed by individual people, human beings. Everyone puts in a little bit of how they like to do things. So that's why it's inconsistent, right? That in the Numpy version, you would specify delimiter. In this one, you don't have to by default. So it's kind of how it is. But they do become consistent over time. Anyway, I'm pretty sure you can specify other delimiters for this. All right, so now that we have that, as I was saying, it doesn't just have to be a file in your file system. You can also do things like, you can also do things like HTTPS, like that. So if you have a CSV somewhere online and you want to get that CSV, like if I have, one test that you guys can try out, go to my GitHub. I'm pretty sure on my GitHub, I have some IRIScsvs. Load that in from the GitHub, and it should load it. Okay, if we have time today, we'll play around with that. There's also Kaggle. Kaggle has a lot of data sets. There are data sets, major research groups have UCI.edu has a lot of data sets, etc. So there's a lot out there. Anyway, so we're trying to bring in the data from a CSV. So let's keep the simple example of loading it from the local system. So now let's go ahead and take a look at what it looks like. So I'm going to do print, and let's try print data frame. Let's see what data frame gives us, because it's a pandas object. So let's see what is actually there. So let's save it so I don't forget. Run. And you can see there, pandas actually brought it in all together, all your data. It says here it posted it in array form. Well, yeah, this is a pandas data frame. So as you can see, it will make up these indices, but they're only kind of external. They're not in the data set. It's just a pandas thing. So you can see it's got 0 for the first. Yes, so pandas makes it easier for sure. So the 0 is the labels. And then we've got the label name, sorry. And then we've got the samples. See, it's 151 rows, including the header, and 5 columns because it's the features. And then we still have to deal with the labels that are words. So we will have to get rid of those. So we want to now grab our data, just the data, as matrices and vectors. So if you remember at the beginning of the semester, I showed you guys to slice data out of matrices, and you also hopefully played around with that when you were doing your homework for Numpy, your practice exercises. So now I need, remember, it's always about getting X and Y. That's the game, okay? X and Y. So now I'm gonna get X, and I'm going to get Y. Remember, the convention should be to use uppercase for X, lowercase for Y, okay? Because Y is a vector, just an array, a one-dimensional array in a Numpy format, and X is at least a two-dimensional array in a Numpy form. so let's go ahead. And grab the data. So to grab the data from, now remember, pandas is a DF, it's a data frame. It is not a Numpy array. It's not a Numpy format. It is a pandas format. So it's important that you label a DF so that you're reminded of it. So now we're gonna try a couple of ways of getting the data. So there's, if I remember correctly, we can try something like this. And I'm going to slice all the rows for X. That's why I use a colon. And then I need all the rows except the first one, right? So I'm gonna start at 2. No, wait, sorry. All the rows, and then the columns should start. Let's just try it from 2 and on. Let's skip the first one. I think that's wrong, but. And then I'm gonna do dot values, which is grabbing the values themselves. So let's just do exit, actually. Let's try that one. Okay, so it didn't error out, so it's okay with it. So now, since I'm trying to figure it, now, I actually want, so I'll ask you this question, actually. This is a good question to ask. Notice that I have this, right? This is the original data frame. I need the data for X. So which of this data do I need to slice out for that? I just need X. So tell me. Actually, you guys tell me the slicing mechanism. Columns 0 to 3, okay. Not the fourth one, right? Because the fourth one would be the labels, right? So I see where you're going with that. So I agree. So 0 to 3 is equivalent to from the beginning to 3. Yeah, okay. So let's try that one. So we would get the values for that and then all the rows. So let's print out X. Let's just figure it out. We got to figure it out. And the only way to do it is by printing it out. That's why I usually also, whenever you're writing code, I recommend that you run it first on MNIST and IRIS, regardless of what your data is, because you know MNIST and IRIS, you're familiar with it. So you can tweak it, tune it, and then once you know you got everything correct, then you just put your own data in that same format and you should be good to go. All right, so now we're gonna run this X and just see what it looks like. Okay, here we go. So as you can see, we've got the original data here and the sliced out data is down here. Looks like the columns are correct because we have 4. Do you guys see that? And we have that, but do you guys see a problem?
It doesn't show classifications.
We haven't done that yet.
Oh, okay.
But at least there is a problem.
Is it not aligned with the columns?
It's aligned. It's aligned. It will be aligned. Look at the data. It's right there. Look at it. What's the problem? What do you mean by it needs parsed? What does that mean? It's not out of order. It doesn't randomly grab them. It grabs them.
Does it say there's 5 columns when there, I mean, it shows there's 4, but it says there's 5?
This is actually from the previous one.
Oh, never mind. Okay.
Yeah, no, that's a good one, but it's the previous one. It needs columns. It does not need commas. It's an array now. Remember what? So remember. Okay, let's see. Machine learning can only interpret numbers. Look at the first row of the output. What does it say? I'm gonna
First row says pedals, pedal width, pedal length. Each.
Exactly. So the first row of this matrix is words. And it's which words is it? It's the words of these words, right? But we don't need those words anymore. Those are just for reference. The machine learning algorithm does not need them because it only needs the order, which it has. So we're going to go back here. So how do we fix the problem? How do I remove that? How do I fix it? What do you guys think? Slice it out. How do we slice it out? You understand? Not the column. We don't need to remove a column. We need to remove the first row. So instead of doing all the rows, now I did all rows from 1 to the end. You see that? Getting rid of row 0 should get rid of that heading. And I don't have it anymore. If I run this, see, solved. It's gone. You guys understand what I did? Yes, exactly. Remember, machine learning only needs numbers, okay? So is this clear, guys? This is important because now we have our X, right? We got it out of the CSV. A lot of CSV will have that header in there. And so you need to be able to get rid of it. Slicing here becomes very crucial. And that's why you needed to practice this in the Numpy example. So I recommend, if you don't remember, go back to it because this becomes more and more important as we start going. Also, on the exam in 2 weeks, you'll get a lot of problems on that. So let's go ahead now and do the next one, right? So we're going to do the next one. I'm going to clear this one out. And now we're going to do the Y. So Y will be, again, data frame dot LOC dot values. But now you guys tell me, so exam type questions will be like this. Now you guys tell me, how do I slice the labels out of there? So what's the answer?
You'll want to slice out the first row, just like we did in X, and then the Y will just be the fourth column.
So like this,
Yep.
You're saying like that?
Yep, like Muaz is saying in chat right now.
Muaz said something? All right, wouldn't it be, okay, let's see Muaz. He said 1 to the end, very good. And then he is saying actually, after the comma, everything until 4. Do you see that, Muaz? You're actually saying a range of 4 columns. We only want the last one. So it's even easier than that. If we just want one column, what do we say? Very good. Perfect. So now, or what Jake wrote, that also could work. Leonard, say start at 4 to the end, but that actually, I think, will exclude 4. So what you can, but the simplest thing is just if you just have one column, plug in one column. You guys see that? Let's say you wanted to select several columns. You can put a little list in here and just say 2, 5, 7. It'll just slice those out. That also works really nicely. But in our case, we only need, let's try 4, right? And that should contain the labels. So now we're going to do print y lowercase, oops, sorry, and let's run this one. Let me save the file. Run. And then now run this one. Okay, we've got our data that we had before. Let's see if we got the labels. There we go. You see that? We've got the labels, but we still have, now this word, obviously, right? It only contains the labels. It's only a vector, if you notice, from beginning to end, because it doesn't have the double thing here. You know, a matrix will have the double, saying it's a matrix and everything inside is a little row. But here it's only one. So it's a vector. But this will not work, unfortunately, because machine learning, Numpy, you know, tensors do not support the words natively. So you got to convert it to numbers. You got to do that. But is this making sense? Is this clearer now? Okay, so it sounds like you guys get it. So now, what we need to do to that y is we need to process it. Now, like I said, you could have done this in Excel outside. You could have written your own Python script in pure Python and solved it. However, we can actually take advantage of sklearn here to do it for us. Okay, so we're gonna do here so we're gonna go to our imports, and we can say from sklearn dot pre-processing import. Oops, sorry, import, and we're gonna call this one. We're going to import a module called the label encoder. Label encoder. So now I'm going to try this one out. Save it. Just to make sure. Okay, it ran. So it found the library, no problem. So now in here then, we're going to use the label encoder to convert our y vector, which currently contains words, into numbers. And it should be pretty straightforward. I'm just going to do, so now I have label encoder. So I'm going to create an object, call it LE for label encoder. This object is going to be of label encoder type. Okay. All right. And then now I just have to teach it what the data looks like, and then tell it to transform it. So we could do a fit, something called fit, which is to train, and then transform, which is the transformation. Or we can do it in one line just by saying y equal LE dot fit and transform. Just like that. And then what is it going to process? Obviously, it's going to process the y. So it's going to do that. So to make this a little bit more obvious, I'm going to just add a little comment here. And I'm going to say changes a string, a class label. Let's say a label string into integers. Okay, So that should do it. And now our y should be transformed into numbers. So what I'm going to do is I'm going to print y before and after. Print y there, and then y after the processing. No need to change the name. So now let's go ahead and run this one. Okay, we've got our data there. This is the original data, right? Then we've got our data as words, and then now, yeah, we're printing X, and then after this should be Y. There it is. You guys see that we did it? So the first 50 were converted to zeros, the next 50 were converted to ones, and the next 50 were converted into twos. Now, I'm not sure in MNIST what the data looks like, okay? So you'll have to, maybe that it's already numbers. If it's already numbers, you don't have to convert it to integers. You should always, something like machine learning, the data is very important, that you spend some time looking at it, thinking about it, you need to become like, you have to know the data very well. Guys, is this clear?
Yes.
Are there any questions? Because this is important. We are almost done. All right, clear. All right, so now that this is done, now because this is creating too much like bulkiness, I'm going to just comment it out. So let me clear the, because now we're going to run everything again, but this time around, we're going to load it. We're going to run it with the data we loaded from the CSV. So I'm just going to comment out all of these. So these are commented out now. And so now I have my X and my Y ready to go, right? And then once I have my X and Y, they're going to plug in here nicely into my train test split. It's going to split it into 70% for train, 30% for test. And then it's just the exact same thing we had done before. It's going to run through everything, do the analysis, and print the results. So let's go ahead and do all that, see if it runs. Hey, I'm still printing some. Oh yeah, the data frame. See, it took it. That's a good thing, right? It took the X and Y. So run. Oh, there's an error there. What was the error? Because everything is not strings anymore. That's a strange error. You guys are following along. I don't know if you see what the problem might be. Let me run this. Text, predict, adds the result to a list. Unsupported operand type S, string and string. What is that? So we got our X and our Y. We've converted Y. It's definitely not a string. Okay, I'm gonna run this. See it. I don't see any. I think the problem. Let me do this. If I do print X here, I think we'll notice what's the issue is. Yeah, you see that, guys? So this, when we print the first X, notice that the values are not strings. Do you see that? They're just 4.4, 2.9. But when we, no, but that's, which one is this? Yeah, that's this X here that I just printed. Because there's no other prints in here. When I get the data of IRIScsv, which is going to be this statement here, and I run it here, these values inside are in single quotes. You see that? Instead of, they don't have commas, but they're in single quotes instead of being in none. So I think that's where that string is coming, that string error is coming from. Do you understand what I'm saying? Like this is a string in single quotes. This is a number, a float, basically. So I think that's the issue. And so we need to solve that one for this to work. Everyone with me so far, the error?
So the error is that they're not strings. If you want to convert the, we want to convert strings to integers, right?
They should not be strings.
Yeah, it should be integers before strings.
Floats. But they currently are.
Gotcha.
So that's what we need to solve here. So that I thought by default, read CSV would take care of that, but apparently it doesn't. So how do I make it? That's interesting that it did it that way. So all right, so let me try. I'm gonna try this. You guys should be seeing. So since the problem would be here, I'm going to say X should now be X dot as type float. Let's see if that works. Okay, so that's, I'm trying to convert those strings into floats, you know, by typecasting it. I'm surprised actually that it didn't do it automatically. So here is where it should error out if it doesn't like it. Okay, it didn't error out, right? So then let's try it again. Okay, let's look at the data now. Do you guys see that the single quotes are not there anymore? They're not integers, these are floats. Okay, integer has no decimal. These are important terminology you need to get right. All right, so now, okay, so good. Let's try the next part. So let's run everything. And this is where it errored out before. Okay, no errors this time. And actually it did it, right? So let's test it. Do we see any errors? Doesn't seem like it, right? Oh, I'm still doing the list. Why am I still doing it? Okay, anyway, I think it's at the bottom that I do. Yeah, here. All right, so this is a little bit better. So they're still pretty perfect. Yeah, all right. And then let's do the last one. All right, and that's it. So that should work. You can see that we went through the whole pipeline of loading your own CSV, doing all the processing that is required with errors and everything. And we were able to run that data set on your KNN algorithm. This is literally your first complete pipeline of machine learning for one algorithm, KNN. Then after that, there are many other algorithms like naive Bayes, which we will study, decision trees, support vector machines, multi-layer perceptrons, logistic regression, and so on. Is this clear, everyone? Is this clear? All right, good. So what I'm gonna do now is, and we have about 9 minutes left, so I'm finished with this script as far as I can think of. I can't imagine anything else. So I'm gonna save this file into the GitHub. It's gonna be called KNN and metrics. And I'm also going to create the assignment for you, okay? The assignment for you. So give me a second here. I'm gonna save this for sure. I'm gonna also save it as, I like usually also saving it as a Python. KNN and metrics. And then just let me, so I'll leave the, put up the code here. All right, do you guys have any questions about the code by any chance? Any questions? All right, so clear, good. Well, I'm glad. I'm glad because we are definitely moving. This actually concludes, if you will, this, as I said, this initial chapter. This was your super basics introduction to machine learning. I am going to assume you understand everything that we've done so far. On Monday, we start a new thing called singular value decomposition. It'll probably take a couple of weeks, but it's a very nice thing that we're going to do. In particular, I think you will like the homework for that one, it'll be a recommender system. So I'm going to ask you to recommend movies or something along those lines. So like we will understand how Netflix, at least in a very simplistic way, right? Because I'm sure Netflix has some secret algorithms in there. But we're going to understand how Netflix kind of goes about recommending things to you. Also, you know, it's going to learn if you like sci-fi or romance or something like that. And also how Amazon recommends books to you or things like that. All right, so that will be the topic of singular value decomposition that we will be starting on Monday. So right now, let me just create the assignment over here. So I need to open up Brightspace. I'm going to go to Brightspace. Okay. And you just have to do this assignment with MNIST, right? Which you have used for the WECA example. Now you will be using it for this one. So let's do. Okay. There we go. So when is the WECA homework? Is it due tonight? Is that when it's due? The soft deadline is tonight. Okay, so you have some time. All right, so I'm going to share Brightspace. All right, so you should be seeing Brightspace now. I'm going to click on content. And like I said, so we've wrapped up. Oh, we have the t-test. Yeah, I may do the t-test also on Monday, but that's not going to be very long. And it's a very independent kind of a topic. So that's. Oh, good. So how long did it take you, Leonard, to run the multi-layer perceptron? 50 hours. What do you have on your computer, if you don't mind my asking? Like what are your specs? Mm-hmm. That's interesting. You were running it on MNIST, correct? The 50 hours? Mm-hmm. Yeah. Anyone else took 50 hours, or some of you took less than that, a lot, significantly less than that? All right, 40 hours. And you have 32 GB of RAM. That's pretty good. Okay, yeah. As I said, the whole point of doing that is that you are motivated to learn other frameworks for big data. Remember, MNIST is by no means big data. Okay, so you had, this was KNN. As we covered it, this was performance metrics, and you have a homework assignment, WECA analysis. Now I'm gonna add a new module here. Just gonna call it I'm gonna call it KNN and performance and metrics. Okay, comma read CSV. Okay, I'm gonna create that module like that one. So I'm gonna just move this one up. And I'm gonna move this all the way up. So this is going to go here. After performance metrics, KNN and metrics, read CSV. All right, so this will just be for the homework. So I'm gonna create a new assignment. Okay, so you're seeing this homework. KNN metrics, and MNIST. Okay, so that's the homework assignment. This will be due a week from today. So today is the 2nd. So it'll be due on the 9th by 10. It'll open today. And then it can stay, it'll stay open. So it's on the 9th. So it'll stay open until Saturday, the 12th. So using the Python, KNN, and metrics code, run the ML pipeline on the MNIST CSV file located on the course website at www. You can find it there. You guys know it's there, right? So you can just get it from there. So using the Python, KNN, and metrics code, run the ML pipeline, on the MNIST CSV file located on the course website at that. Report F1 measure, precision, recall, confusion matrix, etc. And also, performance, right? See if this is faster, a little bit faster. You are using some good libraries with Numpy there. Let's see. There are some inefficiencies in the code. I'll point it out. I'll point it out in a second. Now, is this clear enough as far as the homework, guys? Is this clear enough? All right, great. So I'm going to save it. Let's go back to table of contents over here. All right, so I've created it now. You can see that there. So there's the homework. As I said, when the class is over, I'll load the code on GitHub. So don't worry, just look for it by name. Yeah, so that kind of concludes it. Let me just point out where the inefficiency is. So the inefficiency, so now you should be seeing that code, KNN and metrics. The inefficiency is really here. It's really here. This line of code, for loops are always your enemy when it comes to machine learning. And the way that I'm doing it is I'm actually comparing one vector to every single vector once at a time. So it's like I grab a vector and I compare it, then another one, then another one. But I have a ton of these, right? So a better way would be to compare a batch of them, right, to another batch. So it's like, compare them. And so this is what we're gonna, where the inefficiency of it is. So definitely that part of code could have been written better. I'm actually not sure how that's gonna do with your MNIST data set because it's much larger. You'll just have to see, okay? Now, one suggestion for those of you that it took 50 hours for this to run would be the following. So let's switch over back to Brightspace. If we go to the course website, so you should be seeing this one. If I go over here, right. So in the course website, you remember that I have the three data sets, IRIS. Now there's MNIST train and there's MNIST test. What you can do is if your computer is too slow, remember that this one is 60,000 samples. This one is only 10,000 samples. So for those of you that maybe have a powerful computer, use the train set with 60,000. For those of you that have maybe slower, just use the 10,000 test set. So that will save you a little bit of time. Does that make sense? Okay, and then let me just look at this file actually. Okay, so I'm going to share this. The last thing, we'll wrap up here. This is, I just opened the MNIST file. So if you notice the first row, it's actually similar to the iris row, right? So you'll have to get rid of it. Now the label, where's the label located? The label is at the first column. Notice that in iris, it was at the end, correct? Notice that here it's at the end, at the beginning. So you'll have to slice differently. Also notice that the labels are actually numbers already, but it might interpret them as strings. So just watch out for that. But yeah, that's it. All right. So we'll wrap up here. I'm going to stop the recording.